Hello everyone. Welcome to today's webinar, Going Beyond the Basics in Post-Processing. My name is Yitong. I'm an engineer in the Arab Birmingham office, and I'll be guiding you through today's webinar. So, in today's webinar, we're going to talk about all the different tools in the Oasys post-processing software which can help make our daily workflow more efficient. So some of the things that we're going to talk about would be such as the advanced best practices for using the Oasys post-processing software more efficiently. Then we're going to talk about some top tips and tricks as well of comparing results, whether it's between multiple CAE models or if you have a CAE model that we want to compare with test data, whether it being test pulses, images, or videos, we're going to show all the top tips in comparing these data. We're also going to talk about the tools that's available in the Oasys post-processing software to enhance communication of results. This could be regardless towards a audience which is technical or a non-technical audience as well by using tools such as Annotations and Bookmarks. Besides that, we're going to talk about how the Oasys post-processing software can help support easier collaboration within teams and share analysis conclusions with one another using tools such as Cutdown PTFs and our web-based browsing tools such as D3PLOT Viewer and also Report Viewer. To automate results, we also have Oasys Reporter, so we're going to show you how to make simple Oasys Reporter templates to automate all of these results generation that we talked about previously. And through all of this, we're going to be using some real-world examples and case studies to demonstrate all of these tools and the Oasys post-processing software. So without further ado, let's get into it. So the first thing that I'm going to start talking about is changing properties of D3plot models. So this is something which is quite simple, but it can be quite powerful in terms of communication of messages as well. And let's take a look at the slide below to understand more about this. So in presentations, sometimes by updating the properties such as the transparency, the coloring, or even the display modes of entities, whether those entities are displayed as shaded mode or they're contoured on different things, such as plastic strains, this can often help communicate a specific point to the audience. So let's take the image below as an example. So below, by highlighting the motor as blue, this emphasizes the motor's contribution to the dash intrusion observed over here. So to an audience in a live presentation when there's not a lot of time to absorb the information that you're trying to get across, having these images with properties well set up could help transfer what you're trying to say to the audience much easier. So D3plot and THIS presents many tools available to help update model properties, and not just that, it can also help transfer properties from one model to another. So when you have two models which are quite similar to one another, then these properties can easily be saved and transferred to a new model the other time when you open it up. So at this point, I'm going to open up D3plot so that we can have a look through together of this model over here. So in my screen over here, I have a MPDB, which stands for Mobile Progressive Deformable Barrier, impacting a rigid wall. And this is sort of part of a calibration test that we were doing. And you can see that on here, I've already have the properties of this model set up whereby I colored the wheels black, colored the trolley as gray, and so on and so forth. So all of these properties of entities can be changed easily by using a combination of the quick pick menu or just right-clicking boxes across the screen. So in the quick pick menu, if I press over here, you can see that there's a lot of different entities that I can choose from, such as parts, entities, includes, nodes, and so on and so forth. So what this means is that whatever you're dragging on the screen next, the changes will be made to the specific entity that you've chosen. So for example, if I chose parts over here, and then if I just right click a box over the screen, that means that any parts that's chosen in this box over here, I will be applying the changes to all the parts inside. So if I let go of my right mouse click, and you can see that there's a lot of options available for me to make changes to these 25 parts that's chosen, such as changing the color, the transparency, display mode, and so on and so forth. So if I change the color, for example, to red, then you can see that all of these changes get reflected instantly. If you don't like the changes that you've made, you can always click on the middle mouse button to undo the changes that you've made as such. Okay, I'm going to do that again and try to color that as red. So you could essentially try changing a lot of different properties. So I'm going to try again, changing maybe the transparency of the front half over here to 50% maybe, so you can see the changes when I drag the screen around. And every time when you open up a new model, you wouldn't want to, if you have a lot of like similar properties with your model, you're just changing a part or two. You wouldn't want to remake all of these properties that you've changed. So essentially, we could also save all of these properties that we've set by using the Properties tool under here. So go into D3PLOT Properties, then you can see that there is a button called Save. That allows us to save a .prp file, which stands for a .properties file. And once you save this .properties file, every time when you open up a new model, what D3plot will do is that it will look through the directory that your PTF files or D3plot files are in, see are there any .prp files, and try to match that. So to demonstrate that, if I click on File, Open New Model, you can see that if let's say I were to open up this same model, D3plot over here has detected that I actually have a .prp file inside the same directory as well. So it lets me choose whether when I open this new model, whether it wants to read the property files that are already saved in it. So I'm going to say, yes, I would like it to be ticked. And if I read it, you can see that it's essentially already colored based on what I've set and saved beforehand. So that's the power of a properties file. And just a note as well is that these property files are reflected in both D3plot and Primer as well. So if you open up Primer, and then Primer can also read the .prp file to have the same sort of like color transparency settings as what you've done in D3plot. So that's the first thing regarding properties. When you're comparing two different models together, there's a lot of different tools that can help easily make changes to both models of different windows at once as well. So for example, the first thing is by clicking 0 on your keyboard. So if I click 0 right now, where my screen is on Windows 1, what that means is that the view of Windows 2 is going to be updated to be the view of Windows 1 as such. If I have my caps lock turned on, that means that whatever changes I make to Windows 1 in terms of the view will be captured in Windows 2 as well. And that's not it. So blanking can also be carried forward from one model to another easily. So to give an example, if I were to blank some of these parts over here in Windows 1, if I right click and then I click blanking to all models, what that means is that instantly my blanking will be carried. Oops, that didn't work too well. Blanking and other properties can also be carried from one model to another directly on D3plot. So there's a few ways that we can do this. So for example, in Windows 2 Model 3 over here, if I were to blank some of these parts, and I want the blanking to be reflected to Model 1 as well, I can simply right-click on the screen and click, for example, blanking, transfer that to all models. You can see that instantly the blanking of Model 3 is transferred to Model 1 as well. Okay, so when you're confused about the difference between such as blanking Model 3, blanking all models, remember that D3plot always has either a question mark or like a help menu, which can give you more explanation of the difference between these different settings as well. So if users would like more flexibility in the type of things that carry forward, you can always go to properties over here. So again, Let's say I have Model 3 toggled on in my properties menu over here. If I click on this arrow button over here, what that means is it's going to transfer all of these properties from Model 1 directly to Model 3. But I could also have a bit more flexibility in this if I click on the three dots over here. This allows you to choose which model the property should be carried from and the things that needs to be propagated. So for example, I can choose to propagate all properties, not just blanking, and I want it to copy to Model 1 and Model 3. So once I click Apply, you can see that not just the blanking, but the coloring inside Model 1 is already carried forward to that of Model 3. Just another note, users should not get confused between properties and settings file as well. So by saving properties file out in D3plot, the properties file contains information about the model properties. So this could be about the coloring, the transparency, and visibility of the entities in your model. So if users were to save settings file in D3plot, this will also contain information about the D3plot window settings, and this will be model independent. So the things that will be saved out would be such as the background color, the contour levels, the data components, and so on and so forth. So next, we're going to jump into THIS. So we're going to look at how we can change properties of THIS curves and make comparisons between THIS curves of different models. In a previous webinar, we've discussed how the different Oasys pre and post-processing tools can be coupled in one session. I'll put this link as well into the comment section below because that would be very helpful for you to help enhance your Oasys workflow too. So in a nutshell, in D3plot, users can also just click on the THIS icon, which is highlighted over here, and this would essentially open up a linked THIS session too. So at this point, I'm going to jump into D3plot to show everyone how we can do this. So I have two new models open up on D3plot. So basically, this allows us to have a bit more comparison when we're looking at the results on THIS as well. So essentially, they are both the MPDB barrier, but they're just impacting different impactors. So by pressing THIS over here, I'm going to open up a linked THIS session. So now we can see a linked THIS session are being opened, and you can see that by default in THIS it's in red, read, and it also shows certain things which are in green, and these are essentially the items that we choose the output from our LS-DYNA run. So these are essentially controlled through a star database keyword when we're setting up the model in Primer. So what I'm going to do now is I'm going to go into Nodes, and I'm going to read the x velocity of the barriers for Model 1 and also Model 2. So THIS has a lot of functions that we can do directly on the graph, and what I like is that it's very easily accessible. So for example, if I want to get the accelerations of the barriers, I can instantly just use a right mouse click, drag a box, go into functions over here, operate, and differentiate my velocity curves to obtain the acceleration curves. Okay, so I don't want my velocity curves over here anymore. I just want to see the acceleration curves. So I can go into curves over here and blank out the first two velocity curves over here. And if I click on plot, you can see this is updated so that I just have the differentiated velocity curves, which is essentially my acceleration curves. You can see that there's a bit of noise as well. I can clean that up directly with a filter. So I can again drag a right box over here, go into functions. In our automotive functions as well, there's a C180 filter. I can use that. Again, you can see now these curves are much smoother. And to get like a better comparison or better visualization, I could reflect the curves up over here as well so that it's above as such. So by dragging, oops, let me get that back again. By dragging a left mouse box over here as well, I can also just blank curves directly on THIS. So very simply, I essentially am able to get the acceleration curves of both Model 1 and Model 2 together in a linked D3plot session as well. Um, so before we go further into this, let's clean this up a little bit more as well. So we could essentially, first of all, clean up the curve titles. You can see that the curve titles over here, they are essentially based on what you've read in, and also the steps that you perform, such as differentiating, and then using a filter which automatically regularizes your curve as well, and so on and so forth. So I want to rename that to be a bit more sensible. So maybe for this one, inside curves, I can change the curve title, maybe to become quarter impact, C180 barrier, X acceleration. Okay, and I can copy and paste this, and I can name this as rounded impact. So now it's much clearer for any audience or for us as well to keep track of what's over here. I could also go into styles. That allows me to change the style of my curve. So for example, I think that these two curves, I like their colors, but they are a bit too thin. So I could click on these two curves, go into width, and maybe increase the width of the curves. So now it's a bit clearer when I save out any images or videos as well. Next thing is perhaps I want to change some stuff such as the titles, the axes, and so on and so forth. So I can go into title and axis to do that. So maybe the title I want to have like a new title. So let's say this is MPDB impact comparisons. I can do that. I want to give appropriate sort of units to my time to become seconds maybe. Change the decimal places of the x-axis. Same goes to my y-axis. It's acceleration. I can give it an appropriate unit and also appropriate decimal points. And if we think that the sizes of these are a bit too small, we can also always change the sizes of all of these as well. So to make something a bit more clearer. So by just using a few sort of like comparisons, sorry, not comparisons, a few different tools, I can easily make these curves much more look much nicer so that when we were to save it into images and videos, it's much clearer to show our point. So we talked about opening THIS in the linked D3plot session. I think the main advantage of this would be the timelines option in THIS, because what this means is that if I were to zoom in my D3plot models as well, better, and press 0 to get them in the same view, and if I now play the animation, you can see that whatever's happening in terms of D3plot, it's all reflected in the THIS graph as well. So this allows us a better comparison. For example, if we're looking at pulses, to see, for example, why there might be drops in acceleration and so on and so forth by comparing it to the animations that we're currently seeing on D3plot as well. So I think that's quite a powerful tool, the timeline option. So a few other things to talk about which can help. We've done a lot of changes to these curves over here. So if I right click on one of these curves and if I were to press on history, it brings out this curve history table over here. So if let's say you have a graph and you've made so many changes to it, you want to track back and see what exact changes that you've made or change the way this graph is set up, you could go into curve history and it tells you directly all of the histories that's being done. So we read the curve, we differentiated the curve, use a filter, and then multiply it by -1 to y. So you could change all of these as well. So for example, instead of differentiating, I could do something else over here, such as, let's see, like a square root maybe, and then I could click on update curves, and then that would essentially change this curve as such immediately. So I can go back to differentiate as well. Hopefully I can find that easily. Alright, that's alright. But you get the point. We can easily change that back as well. If I now right click on square root and then go back to the differentiate set and update curve, you can see that the curve reverted back to what it used to be. So the curve history is a really powerful tool to check back on the steps that you've taken to obtain the current curve, or make changes to the operations involved. The next thing that I'm going to talk about is the Y2 axis. So inside title axes, you can see that there's x-axis, y-axis, and y2 axis, which stands for the second y-axis. So having a second y-axis can be quite useful as well, because imagine if you're comparing two different things, such as acceleration and forces. It might be good to overlay contact forces with also acceleration pulses at times as well, because it allows you to see and track, are there any contributing factors causing the drops in pulse, for example. And we wouldn't want these forces and accelerations to be in the same y-axis because their order of magnitude might be quite different. So what we could do is we can read one of them and put it in the second y-axis. So let's try that. I can go into y2 axis and add a second y-axis over here. So you can see we've now added a second y-axis into our t-his. So I'm just going to focus on maybe model 1, okay? And then just have the model 1 curves on. So this is the model 1's acceleration curve. I'm also going to read the contact force between the trolley and the barrier for model 1 as well. Okay, going to read the magnitude force and apply. Okay, so what I want to do is I could essentially go to my curves, and you can see that there is a column over here called Y2. I can click on this so that if I click on plot now, it essentially moves the selected curve into a Y2 axis. So now we can have like a better comparison between the acceleration and the pulse without having magnitudes which are very different from one another. You can see from the legends over here which graph corresponds to the y1 axis and which graph corresponds to the y2 axis based on the direction of the pointer as seen over here. Okay, so the last thing that I want to do is to show everyone how we can use the combine operation in t-his to get a force displacement curve. Because a force displacement curve could be something which is quite useful and in day-to-day sort of like workflows in terms of comparing between model to model and model to tests as well. So let's go on and do that. So first of all, I'm going to turn off the second y-axis. All right. So we have the force graph which is already red over here. But now what we want to do is we want to obtain the displacement. So what we can do is we can get the velocity graph again. And now we're going to right click onto this and we're going to operate and integrate this graph to get our the displacement graph. Okay. So now I have in black, okay, to get this clearer, I'm going to toggle off the green graph. We can see the displacement curve and we can also see the force curve. So I can go into operate over here and there's a function called combine which allows me to choose I want the displacement on the x-axis and the force on the y-axis to combine them together into one single graph. And that graph will look something like that, whereby now on the y-axis I have the force and the x-axis I have the displacement. You can see how the timeline changes now into a point instead of a line when it's against displacement. So it can be quite useful to compare model to model using a force displacement graph too. The next two that we're going to be talking about will be the curve table. So one can imagine that when making changes to curves in t-his, we might not just be making changes to one or two curves. There might be 100 of curves that we want to make changes to, and it would be quite impossible to make changes to them one by one. So the curve table is a really versatile tool to perform many of these curve customization functions together in one go. So this includes customizing the placement of curves into different graphs, or using different functions and curve style changes to many curves at once. Besides that, we can also use the curve table to obtain useful properties of the curves such as minimum y, maximum y values, and so on and so forth, alongside annotating these values on top of the existing curves easily. So this is best shown through an example as well. In this this link D3PLOT THIS session over here, I've created a new graph by going under THIS graphs and clicking create. So this allows us to utilize the curve table function to the fullest. So to go into the curve table, I can just press curves over here and press table. This opens up the curve table. And we can see easily that there's 8 IDs over here corresponding to the 8 curves that we have outputted. Besides that, we also have 2 different groups over here called Model 1 and Model 2. These are created by default, these 2 groups, and each of these groups will contain all of the curves associated with Model 1 and also Model 2. So to give an example of how we can customize the curve table easily, if let's say I click on 2 over here, on Model 2, and then I click Update, what this does is that in graph 2 that I have over here, instantly all of the curves associated with Model 2 are now plotted directly onto graph number 2. So you can imagine that, let's say we have a lot of, for example, acceleration data. We can also put all of those acceleration data into a group so that by just one click of the button, we're able to plot all of the accelerations into one graph. So speaking of which, how do we then create new groups? So I can just right click over here and click on create group. I can just enter a group name. So for example, acceleration, and then click on apply. Okay. So now you can see that there's a new graph over here called acceleration. So I want to add these 2 curves over here into the acceleration group. I can just right click them, click add to group, acceleration, and apply. Okay. So now this acceleration graph over here would essentially have both of these curves. So now if let's say I were to click acceleration on graph 2 as such, you can see that this essentially toggles these 2 curves over here. And if I click update, that plots the acceleration curves onto graph 2. So easily creating groups and moving different curves to different graphs. And that's not the only thing. You could also change the styles of all the curves together. So you can perform different functions, perform different color changes and style changes to all the curves inside a particular group together as well. The next thing that's useful inside the curve table will be the curve properties function. So if I click on the curve properties function, you can see that for all of the curves over here, they are giving us a lot of information about the curve, such as the minimum y, maximum y, and so on and so forth of all of these curves over here. And what's useful about this is that this curve properties table over here could be saved into a CSV file. So you could essentially just save it on top over here. Besides that, if let's say there are certain things that you would like to annotate onto the graph directly, you could just right click over here on the particular curve property such as maximum y that you want to annotate, and then just click annotate. And you can see that the maximum y's are now plotted to the graph. And of course, you have a lot of different annotation options as well. Creation of these curves can also be repeated across different models as well. So these creation of curves steps could be saved in these files called Fast-TCFs. So if similar curves and graphs are required to be generated, users can create these Fast-TCF scripts to automate the creation of graphs on similar session or models. So because the Fast-TCF script only records the history of steps performed, you could also use the Fast-TCF script across different models as long as they are similar in terms of the node ID, part ID of the curves that you're extracting, for example. So no actual scripting is actually required by the users for Fast-TCF script. You could essentially just generate it automatically through THIS, and a novice can also edit the input file manually if it's required as well. So I'm going to go back into my D3PLOT THIS session. So Fast-TCF can be found here under THIS. So you could choose to create a Fast-TCF. You can choose whether you want it to be all pages, all graphs, and so on and so forth. and then you could just save it. So in the future, when you have a new model, then you could go into Fast-TCF and just press run, read the particular Fast-TCF, and it would regenerate all of these curves and also the graphs together. At the same time, if I go into THIS now and I want to read a new LS-DYNA model, for example, so if I click on new model, you can see that when you're in reading a new model mode, there is a tick box over here which allows you to choose to extract curves to match a particular model. This works essentially the same as a Fast-TCF file, so you can imagine that when you read in a new model, it will look through the steps performed inside model 1, and it will perform the same exact steps and generate the same curves and graphs in the new model that you've read through as well. So that's essentially Fast-TCFs so that you can streamline your workflow across multiple different models. The next thing that we're going to talk about is pages. Um, so you can imagine that in live presentations, we want to have everything in a very streamlined workflow so that we could communicate messages easily to different audiences. And to do that, we can essentially save a lot of layouts of our D3Plot teacher sessions in the manner that we wanted to present. So to use pages, we can do that easily. So pages can be found under D3Plot Layout, and under Advanced, you can essentially have a page over here called All Pages. So this can be best go through a demonstration again as well. So going to D3Plot, Layout, Advanced, and then going to click off All Pages. So instantly, you can see that many different pages are toggled together at once. So you can choose for each of these pages how you want the layout to be and what windows and graphs of D3Plot and THIS you would like to add to the page as well. So you can see that in page 1 is by default what we have over here. Maybe I can add a page 2 over here. Maybe I want it to be a 2 times 1. Okay, and then I'll add maybe Windows 1 of D3Plot and Graph 1 over here. And then I can do the same for like Windows 3 as well. I just want 1 times 1, and I want to show just Windows 2. So I've essentially customized 3 pages over here. And let me show you how this works. So you can see that on the top right corner over here, there is a Pages tab. So in the Pages tab over here, what we can do is we can click to the next page, and that essentially goes towards the 2 times 1 view that we set up. Going to page 3, that gives us the 1 times 1 view of model 2. So you can imagine that in a live presentation, we can create all of these windows and graphs beforehand, and during the live presentation, we just very easily explain through our workflow and then go through different pages to explain different things where they are already set up perfectly. Speaking of live presentations, the Annotations or Bookmarks tool is also really useful in helping guide users through a live presentation. So Annotations in D3Plot is a versatile tool to guide audiences through different models in a storytelling kind of process. So if you can see on the picture below, we could essentially save different views and plots and also give titles and text as well, so that in the live presentations, users can then easily toggle between annotations to explain like a step-by-step process to the audience during a live presentation. So at this stage, I'm going to go into D3Plot to have to give everyone a sort of better understanding of how animations work. So annotations work. So in this case over here, I've created a few annotations in this model so that everyone can have a look at how annotations behave. And after that, I'm going to show everyone how you can create some simple annotations as well. So you can see that annotations is accessible through the D3Plot menu over here. And in this case, I've saved 3 different annotations. And you can see that annotations, if I go into the playback menu, I can skip between different animations. and each of the animations will essentially have like a title and also have some description as well. So that this is sort of like your notes section when you're explaining to users in a live presentation setting. So I can say the first thing I want to show users is how the end of the honeycomb deformation looks like in the isometric view. And I go into the next one, I can show a animation then of how it looks in the top view. And then I could go into the next view over here, which essentially shows the final plastic strain of the honeycomb deformation. So you can see that not just the views and the blanking have been stored, but even like the sort of like shading, whether it's a shaded view or a contour view and so on and so forth. So besides that, you can also see that there are target markers showing viewers where they need to sort of like look at as well. So this is essentially annotations in a nutshell. So how can we create like these annotations easily then? So when you click on annotations, there is essentially an edit menu. You can see over here that I've essentially created 3 different annotations over here. And to create a new annotation, essentially I can just click onto 4 and then easily create that by going from top to the bottom. So first of all, I can select like a target marker. I can select, for example, like a node to be used as a target marker, showing the viewers what exactly they should look at. So for example, I can select a node and I would say that I want target marker 4 to be here on the wheels, for example. And you can see that creates number 4. I can add like a title saying something like wheels, and then I could choose to add a description or not. And then I could then set my sort of like view. So maybe I want like a side view like that. And then once I'm happy that this is the view that I want to keep as an annotation, I can just click capture. And that captures the annotation instantly. So you can see over here that there's 2 different buttons. There's a play sign and also a video sign. So what the play sign does is that it plays the annotation instantly upon loading the annotation view. So for example, if it's an animation that you want to show the users in the live presentation, you might want to click this over here so that it shows it as a video instead of a single frame animation. The second video button over here, essentially, if when ticked, this exports this exports to the D3PLOT viewer as an animation instead of a single frame. But we're going to leave D3PLOT Viewer for now, and I'm going to discuss that a little bit more detail later on as well. You can see that all of these views over here that I have ISO view, top view, and so on and so forth, I could essentially click on them and I can reload the view instantly. Or if I want to make any changes, so I want to move this view, I can just click update view. So the next time when I go back into number 2, it's with the updated view. I can look at the annotation list in different formats as well as such, so that instead of just looking at the titles, I can look at in terms of like thumbnails as well, which might be more useful in trying to track what each of these represent. So the other thing is that if let's say throughout your workflow, you want, for example, I have like this view over here, and I think, okay, I might want to capture this animation. You could essentially just click this button at the top. It's called a bookmark. By capturing this bookmark, you're essentially capturing an annotation as well, because annotations and bookmarks essentially work hand in hand with one another. Once you captured this, you can essentially go into number 5 and then populate your title, your description, and so on and so forth. All of these bookmarks that you saved can also be accessed in the bookmarks row. So if we go back into edit over here, we can also see for annotations, you could save annotations to a file or retrieve annotations as well. So when you save annotations to a file, these are saved as a .ann file over here. And you could retrieve the animation so that the next time when you open up the same model, then this essentially creates all of those views, blankings, and annotations instantly. The last thing to talk about in terms of animation and annotation is you could also export all of these annotations to a D3PLOT viewer, which again, D3PLOT Viewer will go through this a little bit later as well, but keep in mind this is a very useful tool. So just some last notes about annotations and bookmarks as well. So when you're saving annotations views, it is actually possible to save views with a THIS linked graph as well. So just now in the model that I've shown, we're looking at annotations just in a D3 plot. But the annotations in terms of like the layouts and stuff can be combined with a THIS linked graph as well. But this is only available in D3plot, and you can't save this out into a D3plot viewer. But let's say if you have many models and many graphs to be arranged in a live presentation, we would still recommend using pages instead for now, just for like due to its robustness reasons. And there's a few other previous webinars that we have if you want to learn more about using annotations and bookmarks, which I will also link in the comment section down below. D3plot also contains a lot of tools to help ease the comparison of results, whether it's between different models at once or between model and CAE models and tests, so that it helps communicate messages to audiences much easier. So analysis are often set up with boundary conditions to match set of physical tests. So you can imagine, for example, maybe this will be clearer if I go to D3plot. So in this model over here, let's say we're comparing the sort of like deformation of the barrier when the honeycomb barrier when it hits a rigid wall. So you can imagine that because the barrier is impacting the rigid wall, it's a bit hard to compare between both barriers when, let's say, both the barriers are moving in space as well. So we kind of want the barrier to stay relatively stationary so that we can compare them a bit easier. We could do that easily by changing the deformation of the barriers using a shift deform function. What a shift deform does is that you could choose 3 nodes as to form like a plane, and the deformation of the whole structure would then be relative to the plane. So, for example, if I go into D3plot, deform, and go into shift deform over here, I could essentially choose 3 nodes on my barrier, which I want to define the stationary plane. So I'm going to choose 1 node over here, 2 nodes, 3 nodes, for example. And then this essentially is reflected onto both Windows 1 and Windows 2. I can click Show Nodes as well to just double check and show the 3 nodes that I've chosen. Okay, and then now let's play the animation again. So you can see now instead of the barrier moving towards the impactor is moving towards the barrier instead. And then that makes it much easier for us to compare results, because now our barrier is essentially relatively not moved. So if I play the animation now, you can see that it's much easier to compare the deformation between both barriers in terms of different views. So shift deform could be quite useful in terms of making comparisons between multiple models together at once. Sometimes it might be useful as well to put all those barriers into a single window to make comparisons a bit easier. And we can do that as well, moving multiple models into one window by using the Windows option on the top here. So for example, if I click on Windows and I want to edit Windows 1 over here, I could also move Model 2 into the first window, but we will want to give them different colors so that they're easier to compare as well. So maybe I can say for Model 1, I want everything to be red, and for Model 2, I want everything to be green. Let's click on Apply. So you can see now in Windows 1, we now have 2 models together. Okay, I'm going to go into my layout to try and expand this window. So now, if I compare, I have a sort of like overlay between both the windows, which makes it much easier for me to see what's going on. Let's try to blank out the unnecessary parts to focus on all of these honeycomb. So I feel like this could also still be improved further. We overlaid it, but maybe it's still not as easy to see what's going on. Maybe what we can do next is we can also add like a cut section to it. Because let's say if we add like a cut section, And I'm going to add like a Z, constant Z cut section. So let's say I pick a node somewhere in the middle over here. Okay. And then what I'm going to say is I'm going to have both positive and negative actions omitted. And I'm going to look into a top view. You can see now it's so much easier to compare the deformation between both of the barriers when they are in different colors and in the same windows in a cut section as well. So these are some of the different tools available in D3plot to help with model comparison. The other thing as well is, for example, let's change it to the other window over here. Okay, so we have this barrier that we were looking at just now. Okay, let's say we want to have a look at the plastic strain of this barrier over here. So I'm going to go into the last state, and then I'm going to toggle plastic strain by clicking on SI over here. Okay, so this plots everything as plastic strain. I don't really like the dark blue, so I'm going to change the low plastic strain values to maybe like a gray color. So you can see over here, because everything is quite deformed, it's a bit hard to see which elements are essentially contributing to the plastic strains, as everything is basically scrunched up into one area. So perhaps something which can be quite helpful as well is if we go into deform. Another thing as well, we can go to magnify and turn off the magnification, because now we can see exactly where the plastic strains are developing in different areas of the honeycomb, and that makes comparison of results much easier as well. Besides comparing between CAE model to model, occasionally we will also want to compare our CAE results to physical tests which are performed as well. So D3plot will allow users to overlay background images and videos onto the CAE models, making the comparisons between CAE and tests clearer. And not just that, D3plot also provides many tools as well to help align these test photos and videos to a CAE model. So the idea of this is that potentially we would like to have the background image of the test on Windows 1, and we would like to have our CAE model on Windows 2. So we're going to go through this process and see how we can do that together. The first thing that we would like to do is to get the background image onto Windows 1. To do that, I can go into Images, Background Image, and that will toggle this tab over here. So inside this section, we can add the corresponding background image and just turn it on. By doing that, you can see that Windows 1 has the background image. So the next thing we would like to do is we would like to adjust the CAE as well so that it matches with that of the background image. What we can use is we can use this Adjust View to Image tool, because that allows us to choose different points of the CAE and correspond that to the different locations of the background image. So the more number of accurate points that we get, we give D3plot, that will allow D3plot to also align our results better. So I'm going to click on Add Points. That allows me to choose different points on the CAE model. So for example, this point might correspond to this point. This node over here might correspond to this point. And then maybe this point over here will correspond to this. And I'm just going to add a few more throughout the whole model over here. So maybe this point will correspond to this. And finally, like this bottom point over here might correspond to this. So when you've added enough views, D3plot will let you press Calculate View. And once you press that, then you try to align the points that you've chosen with the CAE model. So again, the number of accurate points you have would correspond to how accurate the alignment is. So I'm not quite satisfied with this alignment, so I'm going to add more points as well. I'm going to add maybe this point over here to correspond with this point, and click Calculate View again. Then at this point, I'm much more happy with the alignment. So I'm going to press 0 to bring the same view into Model 2 as well, into Windows 2, sorry. And now if I press E on my keyboard, that brings out the Entity menu. And I say for Windows 1, I want to turn off all of the entity, so that now you can see between Windows 1 and Windows 2 a much better comparison between CAE and also the test. Then we could go into Image, and then click on images to write out this whole image over here. So this alignment tool not works on top of images as well. It also works with videos. So when we're comparing CAE model to test videos as well, you get more options in terms of like the scaling, the frames to read in our movie, and also for our CAE, which state numbers we want to use, which state would we like to start with, and so on and so forth. So an example would be below. This is an example where we align the test result to the CAE results in terms of like the viewing, and we also adjust the sort of like time frame so that it matches between both of them. So Arup has over 20 years of experience in barrier development as well, and this is just an example of how we correlate our MPDB site shell barrier in collaboration with Selbon. Now, we talked a lot about the different tools in D3Plot and Thesis, which will help with analysis of results and also result presentation. Next, we're going to touch on a little bit on Oasys Reporter, which is a powerful tool to help with automation of generation of results and the preparation of reports as well. So we offer an intro to post training, and this includes an introduction to Reporter as well. So our next intro to post training is actually happening really soon if you'd like to sign up. Or we also have some online introduction to Oasys Reporter videos available as well. But today's session, what I'm going to do is I'm going to shortly introduce Reporter to set up like a very simple template so users can understand the capabilities of using Oasys Reporter to automate both report writing and also results creation as well. So if you open Oasys Reporter, this is how a blank template would look like. The first thing that we do in Oasys Reporter is to allow Oasys Reporter to know exactly which analysis folder we want to be working on. So first, we can go into variables and edit. And the two important things to define is essentially the default directory and the default job over here. So in terms of the default directory, I'm going to head into one of the directories that I was working on, which is this one. So I'm going to pick this testy rounded directory, okay? And then I'm also going to pick the default job, which is essentially the PTF file that I was working on inside that directory. So once you have both of these defined, you're essentially ready to create your your reporter template. Every time when you run your reporter template, if you want to run it in a different model, just remember that you can use the same template and you just have to change the default directory and default job. So what you can do is you can essentially save out different animations, different graphs, and so on and so forth, just as how you would do in terms of like in D3Plot and THIS. But what it does is that you can then finally write this out as either a PDF or a PowerPoint easily just from Reporter. So a few simple things to show. So you can click on the D3Plot icon over here, and I can drag a box to show that this is the D3Plot animation that I want to create, and then this would essentially pop up. And what users can do is click capture, and this would essentially open up D3Plot so that users can decide which exact animation or plot we would like to store inside the reporter template. Okay, let's fix this. Okay, so it opened up this D3Plot session over here. So maybe what I like to do is I want to save out an image of the final slide. So I can do this, and once if I'm happy with the view and everything, what I can do is I can click on Reporter, and I can just click Update on this particular window over here. So once I click Update, and I go back into my Reporter template, you can see that the exact animation is updated. So I can do the same as well in terms of creating a T-HIS graph, and that essentially saves the Fast-TCF of the graph of the curve that I created. But I can also I want to show one other thing as well, which essentially, let's say I create a new D3Plot windows over here, and I'm going to go back to capture, and then I'm going to open up the linked D3Plot session that I have over here. So now we're looking at this particular D3Plot session. So the other thing that I can do is I can isolate out the honeycomb, for example, okay? And then potentially, let's say I want to go to the last state and plot maybe the plastic strain. So I can do that as well. And I want to show everyone something interesting, which is if let's say I have this plastic strain that I'm quite happy with, I'm going to go into my reporter and you can see that now there is a column over here called show variables. So essentially, show variables allows us to save variables in this current D3plot windows and have those variables being used inside reporter. So for example, in this windows over here, I can add a new variable. And because I have plastic strain plotted, I can choose plastic strain and get either the max value, the min value, and so on and so forth. And I can give it a variable name, such as max plastic, for example. Okay, and then I'm just going to give it the same variable description as well. And I'm going to dock it. So what this means is that this maximum plastic strain value can now be quoted in our reporter template. And how is this useful? So I'm going to update this view first and go back into my reporter template. I'm going to try that once more. Go to this. Oh, sorry, it should be Windows 2. And then I'm going to update Windows 2. Go back to my reporter template. So now in reporter, I can also create a table. Okay, I'm going to create a table here, for example, and then I'm going to create a maybe 2 times 1 table, or maybe a 1 times 2 table. That might look better. So in column 1, maybe I'll say that this is the maximum honeycomb plastic strain. And I'd like to quote the maximum value that I've gotten from D3plot just now. So remember that we saved it under max plastic. So by using the percentage signs, I can essentially get the value of max plastic that I've retrieved just now. I can click on OK. So I'm currently under design view. If I now go into presentation view, so now in Reporter, I can go to the table 2 to create a table, for example, and drag a box again over here. So potentially I want to create a table with 1 row and 2 columns. So in column 1, maybe I'll say I want it to be maximum honeycomb plastic strain. And in column 2, I want to quote the exact value, the maximum plastic strain value that I've gotten in D3plot. So what I can do is I can right click on the text and I want to insert the variable. So remember that we saved a variable called max plastic now. So we can click that and press OK. So now when we go between design view and presentation view, you can see that in presentation view, the exact value of the plastic strain is quoted. So Reporter can help you create a table which summarizes all of the different variables as well. So once you're happy with your Reporter template, you can click on File, you can write it as a Reporter template, a PDF, a PowerPoint, and so on and so forth. And note that because we can always go back to our variables to change the default directory and the job, this reporter template can be used in many different models as well. You could also batch run reporter in Oasys shell. So if you open up Oasys shell and you choose batch reporter, this will open up a reporter section options as well. So what you could do is you could choose the different input files and choose the same reporter template so that the reporter would run on all 3 of these models together as one. In Shell, you can allow reporter to decide whether we want to output it in PDF, PowerPoint, so on and so forth, and how we want to run the reporter template. So this is essentially a nutshell of how Reporter can help automate result generation. For people who are just getting started with using Oasys Reporter as well, just to note that Oasys Reporter also has a series of library templates which can help you with your workflow. So you can access that easily by going to File and Open Library Templates. So you can see that there's a lot of different library templates over here to choose from, but certain things such as like, let's say if we go into automotive, you can see that you can filter out different regulations or different barriers, impactors, or different release years and things like that. So for example, if we look at MPDB, which is the one which we're looking at, there's a lot of different reporter templates that's set up so that it automatically outputs the required images, videos, and plots for the regulation. So you can have the compatibility assessment, occupant assessment as well, or there's certain general templates which can help check your LS-DYNA model regardless of whether it's an automotive load case or any or other load cases. So an example of the MPTB compatibility assessment would look like that. So you have like a compatibility assessment penalty score, and it also saves out some animations in different views. So please feel free to explore around the library templates that's available, whether it's the automotive template or whether it's like a general template, which can help you sort of like summarize results and also check your model efficiently. If you want to learn more about reporter templates or reporter in general, here's a few links that's available. And if there are any specific templates that you would like to be added, please feel free to reach out to us as well. So before we end today's webinar session, I just want to talk a little bit more about efficient sharing of results. In today's session, we talked a lot about how the Oasys post-processing software can help in terms of results analysis and result presentation as well. But how do we ensure that we efficiently share our results with our audiences as well? The first thing that I like to talk about is Cutdown PTF/D3PLOT files. So essentially reducing the file sizes for ease of data transfer. So we can imagine that D3PLOT output files are often quite large, so it might be quite difficult and it takes a lot of time to transfer from one area to another or transfer to our audiences as well. So what we can do in D3plot is we can create compressed versions of set D3plot files, and we do this by choosing which parts, which states, and which data components, such as stresses, strains, and so on and so forth, to include. And that allows for more efficient transfer of data. So this is an example where in the MPDB model, I chose to only output the honeycomb and cladding parts in my Cutdown model. Besides that, I also chose not to output any stress tensors, forces, and so on and so forth, so that I just save out the animation. With this, I managed to reduce my file size from 2.4 GB to 1.4 GB, and that makes it easier to share with our audiences. So now I'm going to open up D3plot to show how Cutdown PTFs can be saved. So in the model over here, users can go to Utilities and go to Compress. So once you press Compress, this table will pop up, which allows us to choose the parts and states that we want to be outputted in the Cutdown PTF. Besides that, you can choose whether we want to output it in original format or a reordered format. If we output it in a reordered format, that means that those Cutdown PTF files can only be read by D3plot, but it also means that it saves additional space as well. So for example, I'm going to just select certain parts over here. Maybe I'll select, if I go back to the first state, just the honeycomb parts over here and click on Apply. And then for states, maybe I'll just select like the last states from 7 to 12. And you can see that it gives an estimated of the PTF state size that will be saved out. So again, I can choose from these data components which components that I want. And for here, I'm only just taking the velocities and the accelerations because I just want the animation to be saved, but not the stress tensor, plastic strain, and so on and so forth. If I click on Apply, then PTF Cutdown files will be generated. Note that this does not overwrite the current PTF files. It just generates additional .ptf files with an underscore cutdown inside the name. At the bottom over here, you can see that we can write the selection to a text file. What this means is that all of these selections in terms of like the data components can be saved and read in a future session. So if you're going to be writing out a lot of cut down PTFs for many different models, you might want to write down the selection to make sure that it's always consistent from one model to another. So what if we want to share results with audiences which might not have access to the Oasys post-processing software? Well, let's talk a little bit about D3PLOT Viewer. So D3PLOT Viewer is a free-to-use, no installation and setup tool online, and it allows users to share simple models with clients or other users efficiently if desired. So there's a link over there to access D3PLOT Viewer instantly, and I'll put that in the comments below as well. So this is how D3PLOT Viewer looks like. So I'm going to show everyone how we can save out these D3PLOT Viewer files first. So if I go into D3Plot, there's two ways that we can save out these D3Plot Viewer files, which are essentially also called .glb files. The first way is going into Image and pressing D3Plot Viewer right. The second is, let's say we have these annotations that we set. We can also export these annotations as a GLB file. So remember that if I go back to this view over here, we've mentioned that for the right column over here, if this is ticked, that means that these sort of like annotation views will be saved out as an animation instead of an image when we open them up in a GLB file. So I'm going to save view number 1 and view number 2 as animations, and we can see that together in D3Plot Viewer later. So at the bottom, there is also a button over here called Export the D3Plot Viewer. We can press that button, and that allows us to choose whether we want to save out our current D3Plot session. We want to save out just the current page, certain windows, or do we want to save annotations as a GLB file? So I'm going to choose annotations and with a frame rate of 2, and I'm just going to save this. It also gives a link as well to open up D3Plot Viewer. So once I click on that link and I open up D3Plot Viewer, this is how it looks like. So D3Plot Viewer, you can open up models and you can perform a lot of similar functions just like D3Plot. So for example, blanking parts as such, and then pressing U to unblank everything again, for example. And you can also add cut sections as well to your D3Plot Viewer. But what I want to focus on today as well is that all of those annotations that you've used in your live presentation could also be shared to other users in D3Plot Viewer as well. So you can see that over here, we have the annotations view, which shows everything that we just discussed today. And because we've saved view number 1 and view number 2 as animations, I can essentially play these animations directly on D3Plot Viewer. So this is a web-based tool freely available for all, and these annotations could be shared easily to any users at all without requiring any installations or downloads. So there's a few notes about D3Plot Viewer. So currently, cut sections are not supported when outputting .glb files, but as shown just now, in D3Plot Viewers, users can create separate cut sections on D3Plot Viewer as well. And if let's say we want to have annotations in multiple models in multiple windows, that's also supported in D3Plot Viewer. And we've already mentioned previously as well that linked t-his graphs will not be exported into GLB files. And one last note, which is quite important, is just to remember that animations take up much more space compared to single frame exports. So think about how many videos or animations you would like to export into your GLB files, because they will make your file sizes much larger, and then it might have trouble loading into D3Plot Viewer as well. Besides D3Plot Viewer, we also have a tool called Report Viewer. So report viewer essentially works the same as a reporter template, and we can share these reports instead of a PDF file or a PowerPoint file. We can save out the report viewer file from reporter and send these to other users as well, because what it does is that users can then open up the report template and you can see the report as what we've made. But at the same time, report viewer allows D3PLOT Viewer to be built in as well. So you can see that in the report, then other users can also have the models, spin the models around inside report viewer, and that allows more sort of like accessibility in terms of like and in terms of visualization of results as well. So that's the end of today's webinar. Here's a few links to stay up to date. We do have a link with all of our future webinars or past webinars recorded. Or please follow us on YouTube as well, where these webinars will be posted too. And again, if you have any questions about anything at any point, please feel free to contact us at Dyna Support. So thank you very much.